Okay, everyone, we're going to go over AP number 25. This is 2017 AB6. It's a wonderful review of the differentiation techniques. So let's take a look at that. Okay, so we're given actually three functions. We're given a function f, we're given a function g, and we're given a graph of a function h. So in this AP, they wanted to combine all three interpretations: function rule, table interpretation, graph interpretation. So let's take a look at it. So they define f of x as cosine 2x plus e to the sine x. And they say g is a differentiable function, and the table above gives all values of g and its derivative. And h is a function whose graph consisting of 5 line segments is shown in the figure above. All right. Now, part A says, find the slope of the line tangent to the graph of f at x equals pi. It doesn't say find the equation of the tangent line. It just says find the slope. So that's what we'll do. And the slope of the tangent line to the graph is its derivative. So first, we find the rule of the derivative. And we differentiate these using the chain rule. So the inner function here is 2x. So we differentiate the outer function, which is negative sine of 2x at the inner times the derivative of the inner. The derivative of e to the sine x, well, the inner function is sine x. So the derivative of the outer at the inner is e to the sine x. And the derivative of the inner is cosine x. Now we replace a pi for every x. So we have negative sine 2 pi times 2 equals e to the sine pi times cosine pi. Now sine of 2 pi is 0, so this whole thing is a 0. And sine of pi is also 0. Cosine pi is negative 1. And e to the 0 is 1, so we get 1 times negative 1, and the answer should be negative 1. So that is the derivative of f at pi, or the slope of the tangent line. So this is what the reader is looking for. Okay. Part B says, let k of x be the composition of these functions, h of f of x, and we want to find the derivative of k at pi. Well, again, we've got to differentiate first, and then put the number in, the x coordinate. Now, the derivative of this is the formula for the chain rule. We have the composition of functions h of f of x, so we say it's the derivative of h at the inner, which is f of x, times the derivative of f. Now we put in the pi's. Well, the derivative of f at pi we found was negative 1. And if you answered that incorrectly, if you carried down your incorrect answer correctly, you would get credit. And f of pi, well, we have to figure that out. So let's go on the side. F of pi is cosine 2 pi plus e to the sine 2 pi. Okay. Well, cosine 2 pi is 1, and sine 2 pi is 0. So this gives us 1 plus 1, which is 2. So we put 2 for f of pi. And now we're finding h of 2 times negative 1. Okay, let's just correct that quickly. So h of 2, we look on the graph. Okay, let's just erase this also. Okay, so h of 2, we look on the graph. And on the graph of this, it looks like, and I was really surprised, it's not negative a half. It's more like oh, I'm sorry. I made a mistake again. This should have been the derivative of h at 2. So the derivative of h of 2 is the slope of this line here. And the slope of that line is rise over run. So we could use any point on the line to get its slope. Notice we have to go down 1 here and to the right, down, I'm sorry. We should go up 1 and to the left 3. So the slope is negative 1/3. So the answer to that question is positive 1/3. And there is our answer. Okay, so again, this was the derivative of h at 2. So we had to get the slope of the line. So whenever they ask to get the derivative of a function at a certain point, and that piece of the function is a line, we always get the slope of that line. Okay, now let's look at part C. G at -4 is 5. And the derivative of g at -4 is -1. So we're going to substitute h at 2, I'm going to erase this because I wrote all over it, is not quite -1/2. The correct approximation would be -3/2, because notice at this point here, wait, let me just highlight. This point here, right there, is 2/3 of the way down from the x-axis. So we'll say that that's -2/3. Now, part C says, let m be the function g of -2x times h of x. Now this requires the product rule because we clearly have the product of two functions. So we're going to find the derivative by writing out the product rule in terms of x. Do not substitute at the same time. One rule for the derivative in terms of x and one for the substitution. So it's the first times the derivative of the second plus the second, and the derivative of the first is a chain rule again, because we have g of a function of x, -2x. So it's the derivative of g at -2x, because it's the derivative of the outer at the inner. We don't know what the outer is, so we'll just write the derivative of g, times the derivative of -2x, which is -2. This is the piece that students forgot. Now we're going to put in the number 2, because we have to get the derivative of m at 2. So let's do that. So we have g of -2 times 2 times the derivative of h at 2 plus h of 2 times the derivative of g at -2 times 2 times -2. So I'll write that as g of -4 times the derivative of h at 2 plus h of 2 times the derivative of g at -4 times -2. Right. Okay. Now, g at -4, if we go back to the chart, we look on the chart, this gives us 5, and this gives us -1. And I'll carry down the -2 here. Okay, now we have to fill in these. Now for this one, we have to go on the chart. We know that in part B, the derivative of h at 2 was -1/3. This is by part B. And h of 2, if we go back, I was a little bit surprised that year because they did great on that. And so when we go through the algebra, we get -5/3 plus -4/3 gives us -9/3, and the answer is -3. So that was our answer in part C. All right, and then part D asks, is there a number C in this interval such that the derivative of g at C equals -4? Whenever we see a question like that, we think of the mean value theorem. And they've been asking this more frequently on the free response, both the mean value theorem and the intermediate value theorem. Okay, so we have to show the reader that we know the hypothesis. We said that, now on top, in the beginning of the problem, it says that g is a differentiable function. Which implies that g is automatically continuous. So by the mean value theorem, and you don't really have to cite the name of the theorem, you just have to show that you know it. By the mean value theorem, there exists a C in this interval. So that the derivative of g at C is equal to g of B minus g of A over B minus A. And in our case, B is -3 and A is -5. So we just substitute those in there. G of -3 minus G of -5 over -3 minus -5. We look these values up on the chart on the top of the problem, and we see that G of -3 is 2, and G at -5 is 10, and -3 plus 5 is -3 plus 5 is 2. So the answer here is -4, and that would answer the last question, that there must be a C in the interval such that the derivative of g at C is -4. Okay, that takes care of this AP. I hope you found it helpful. Have a great day.